All right, here we go. So today I'm taking on just a little blended practice, looking at binomial and geometric distributions, kind of wrapped into one big problem. So we're looking at, here's our context. We have an Olympic archer is able to hit the bullseye 80% of the time. So if she shoots 6 arrows maximum, right, we want to find each probability. So first I'm just going to flesh out what are the two options here, right? She could either make that bullseye, which would be 0.8, right, 80% of the time, or, of course, she can miss. So misses the bullseye would be that 20% to complement, so 0.2. So she either makes it or she misses it, 0.8 or 0.2. So first up, her first bullseye comes on the third arrow. So the big identifier here that it's geometric is that we're saying, well, her first success comes on the third try. And prior to that third try, right, she had 2 failures. So here again, let me just write out that this is geometric. And we're getting that success on the third try. So if I'm using my calculator shortcuts, my fancy shortcuts, I'd be saying, well, geomet, PDF, because I'm looking for exactly 3, right? Third try was when I got to that success. So I have 0.8, comma 3. And then I type that into the calculator. So here I'm hitting second verse. I'm going all the way down to geomet, PDF right here, and I'm saying 0.8, comma 3, and I'm getting 0.032. Okay, my next one here, she misses the bullseye at least once. Okay, well, here it's not saying that she, misses on her third try or her 5th try. It's not saying anything like that. It's saying she misses the bullseye at least once. So if she's shooting a maximum of 6 arrows, well, that means that she can miss it 1 time, 2 times, 3 times, 4, 5, or all 6 times. So this makes me think it's binomial. So binomial, because she can miss, like I said, exactly 1 time, exactly 2 times, 3, 4, 5, or all 6. And here again, we're looking at misses. That language has changed as well. She misses 1, 2, 3, 4, 5, or 6 times. So here, I'm going to go using my complement. I'm going to do 1 minus the probability that she misses 0 bullseyes. So 1 minus, well, binom, PDF, because it's an exact outcome, 0 bullseyes. So here I'm looking at, out of 6 arrows shot, the probability that she misses, and this is a crucial detail, misses is 0.2, and we're looking for exactly 0 misses. So 6 total trials, my probability for missing 0.2, and I'm looking at exactly 0 misses. So when I type that in, here I'm doing 1 minus second verse. I'm going down to binom PDF right here, and I'm saying 6, comma 0.2, comma 0. And there we go. So we get about 0.7379. All right, let me slide it up. All right, next up in C, her first bullseye right there, that tells me geometric, right? Her first bullseye comes on the 4th or the 5th arrow. So geometric again, because we see that our first try comes either our first success comes on the 4th try or the 5th try. So geometric. And we're saying that X could be 4 or 5, right? She gets that success on the 4th try or the 5th try. So I need to calculate each of those particular outcomes, and then I gotta add them together. So the first one I'm saying geomet, PDF, 0.84, and then the second one, geomet, PDF, 0.8, comma 5. So here I get 0.0064. Here I get 0.0013. And I just got to add them up. So when I add up the 0.0064 to the 0.0013, I'm going to get about 0.0077. Okay, next up, she gets exactly 4 bullseyes. So she gets 4 successes out of the 6 total trials. So let's see, exactly 4. So I know then it's binomial. And we're looking at 4 successes. So here I'm saying binom PDF, 6 trials. 0.8 is my probability of making the bullseye, and I'm looking for exactly 4 of those successes, 4 bullseyes. So here I'm going to say binom PDF, so second verse, going all the way down to binom PDF. Okay, and I'm looking at 6, comma 0.8, comma 4. So that's going to be about 0.2458. Okay, she gets at least 4 bullseyes, so at least 4 bullseyes. So again, that means that I could have 4 bullseyes, could be 5, could be 6. So I'm going to lay this out as binomial and say that x could be 4, 5, or 6. So then I have to go through the complement. I know that that's 1 minus the probability that it's 0, 1, 2, or 3. So I can go 1 minus binom CDF 6.83. Because that 3, right, that's saying 3 or less. So when I type this in, let me slide it up. Here, I'm doing 1 minus, so second verse, binom CDF right there, and I'm saying 6, comma 0.8, comma 3, because it's 3 or less. So I get 0.9011. Okay, next up, she gets at most, so at most 4 bullseyes. So again, back to binomial, because that's saying she could have exactly 0 successes, 1 success, 2, 3, or all 4. So x equals 0, 1, 2, 3, or 4. At most 4. So here I'm doing binom CDF 6, comma 0.8, comma 4. Because again, it's 4 or less. So here if I type that in, I get 0.3446. All right, now at the bottom, I have 2 questions that are asking about mean and standard deviation. We just have to identify the phrasing as to which one is meant to be binomial, which one is meant to be geometric. So for G, how many bullseyes do you expect her to get with what standard deviation? So here we're saying, well, how many successes do we expect to see if we're seeing that she shoots 6 arrows? So that tells us, well, we're looking at binomial. So here I'm going to say my mean equals n times p. So here that would be 6 times 0.8. So my mean would be exactly 4.8 that are made. Okay, and then here we'd say that like an average of 4.8 arrows would hit the bullseye. Okay, with what measure of spread? So standard deviation for binomial, square root of NPQ. So plug everything in, and that would be square root of 6 times 0.8 times 0.2. So I get a standard deviation of about 0.9798. Right, but again, doesn't really matter unless we know what that means. So here we could say, well, if this Olympic archer, if she shoots 6 arrows, so if she shoots 6 arrows, we expect her to make an average of 4.8 bullseyes with a standard deviation of about 0.9798 bullseyes. Okay, so there is my mean, my standard deviation, add the context, and then for the last one, if she keeps shooting until she hits the bullseye, right, so that language is telling us it's a geometric situation. We're saying, well, how long do we expect it to take, and with what standard deviation? All right, so here when it's geometric, my mean is 1 divided by p. So 1 divided by 0.8, my mean is exactly 1.25. Right, so if we expect her to keep shooting until she gets her target, her bullseye, right, we're expecting that it would take an average of 1.25 arrows. Okay, with what standard deviation? So big square root, q divided by p squared. So we're looking at 0.2 over 0.8 squared like that. So square root of 0.2 divided by 0.8 squared. And when we type that in, we should get about 0.559. Okay, and then again, add the context. So we expect her to shoot an average of 1.25 arrows to hit a bullseye, just abbreviating, with a standard deviation of 0.559 arrows. All right, I hope that was a good blended practice of geometric and binomial distributions. Again, the bigger identifier for binomial, we have a fixed number of trials, and within those trials, we're looking for an exact count of success. For geometric, we do not have a fixed number of trials. We keep going until that desired outcome is achieved, right? So we see it takes so many tries to be successful on, the 6th trial, for example. All right, have a lovely rest of your day. I hope to see you guys soon.